Hello and welcome back to the channel. My name is Nidhi and I am a student studying at Sri Venkateswara College of Engineering, Bangalore. In today's video, we will make ourselves familiar with the concept of circular stack from the course of data structure and applications. First, let's see the introduction to data structures. Data structures are essential in computer science as they provide a way to organize and store data efficiently. By using appropriate data structures, we can optimize the retrieval, manipulation, and storage of data. Proper selection of a data structure can directly impact the performance of algorithms, improving speed and memory usage. In complex systems, data structure are key to managing large amounts of information, enabling better data handling, such as in databases, file systems, and memory management. Data structures are classified into two types: linear data structure and nonlinear data structure. Under linear data structure, data is organized sequentially, with each element connected to the next. Example: array, stack, or queues. Array is a collection of elements indexed for easy access but with a fixed size. Stack is a lasting first out structure where elements are added or removed from only one end. Queue is a first in first out structure where elements are added at one end and removed from the other. Under nonlinear data structure, data is organized hierarchically or in a network, allowing multiple relationships between elements. Example: trees or graphs. Tree is a structure with a root element where each node can have children, but there's no loop. Graph is a network of nodes where each node may have multiple connections to other nodes, allowing more complex relationships. Now let's learn more about stack data structure. A stack is a type of linear data structure that operates based on the LIFO principle, that is, last in, first out. This means the last element that is added to the stack will be the first one to be removed. It can be visualized as a vertical collection where elements are added and removed from the top, much like a stack of plates. Moving on to operation of stacks, push operation adds an element to the top of the stack. The stack grows as the elements are pushed into it. Pop operation removes the element from the top of the stack. The stack shrinks as element pop off. Application of stacks. Stacks are used in expression evaluation, recursion, and memory management. Function calls are managed using a stack, where each call is pushed onto the stack and popped off when the function completes. In memory management, stacks control memory, especially for function calls with local variables. Let's go through the limitation of traditional stacks. In a traditional stack, operations are based on the LIFO principle, which means that all insertion and removals occurs only from one end, that is, the top of the stack. While this is useful in many applications, it introduces limitations when dealing with more complex or dynamic datasets. Traditional stacks can become inefficient when holding larger or more complex datasets because they only allow access from one side. As the stack grows, the need to access elements deep within the stack requires unnecessary operations. This single side access can lead to performance bottlenecks in cases where more flexibility is needed. Need for an enhanced data structure. To overcome these limitations, data structures like circular stacks are introduced. They allow both push and pop operations from both ends of the stack, making them more flexible and efficient. This dual side access can significantly improve performance in scenarios requiring frequent insertion and deletion from both sides. Introduction to circular stack. A circular stack is an advanced variation of the traditional stack that allows elements to be added or removed from both ends. This feature significantly enhances flexibility and efficiency, especially in cases where data need to be accessed or manipulated from both the ends of the stack. Unlike a traditional stack, which operates under the LIFO principle and restricts operation to one side, the circular stack provides access to both the front and the back of the structure. This dual side access increases performance and offers a more versatile approach to data handling. Combining stack and circular data management. The circular stack combines the advantages of the stack with the principles of circular data structures, such as circular queues. This hybrid design allows the stack to behave like a circular buffer, continuously wrapping around when it reaches its limit, without compromising its LIFO behavior. This makes it particularly useful in systems that require continuous data processing. Moving on to operations in circular stack, there are majorly four operations that can be performed. First, push front. The push front operation adds an element to the front of the circular stack. This is similar to the traditional stack's push operation, but is applied to the front side. The element is inserted at the front, and the root pointer is updated to reflect the new top of the front stack. Second, pushback. The pushback operation adds an element to the back of the circular stack. This is what differentiates a circular stack from the traditional stack, as it allows insertion at both ends. The element is inserted at the back, and the D pointer is updated to reflect the new top of the back stack. Third, pop front. The pop front operation removes an element from the front of the stack. This works just like the standard pop in a regular stack, but only from the front side. The top element is removed and the root is adjusted to point to the next element in the front stack. Fourth is pop back. The pop back operation removes an element from the back of the stack. This is a unique feature of the circular stack, enabling the removal of elements from both ends. The element at the top of the back stack is removed, and the back stack's top pointer is updated. In the right hand side, you can observe the structure of circular stack, where front stack is the part of the stack where elements are pushed and popped from the front. This behaves like a standard stack operating under LIFO principle, but only on one side. Backstack is the other side of the stack where elements can also be pushed and popped. It allows dual sided operation, enhancing efficiency in data handling. Root is the pointer to the base of the front stack, indicates the starting position where elements can be added. Peak is the top element of the front stack, which is about to be popped during a removal operation. Deep is the element at the top of the back stack, ready to be popped from the back side of the circular stack. Circular stack has many applications. Some of its major applications are mentioned here. CPU scheduling. Circular stacks are beneficial in CPU scheduling as they allow efficient management of processes. By using a circular stack, the CPU can handle multiple tasks, switching between them quickly while maintaining the order of execution. The dual push and pop capabilities allow for dynamic adjustment in task priority and execution flow, ensuring optimal CPU resource utilization. Memory management. Circular stacks are used in memory management systems to handle dynamic data allocation. By maintaining multiple stacks within a single structure, they optimize memory usage, reduce fragmentation, and provide faster access to memory resources. This is especially important in environments where memory allocation and deallocation occurs frequently. System requiring multiple stacks. Circular stacks are ideal for complex systems such as RISC chips and microprocessors, which often require multiple stacks to manage various operations. The ability to access both ends of the stack enhances performance by minimizing the overhead associated with managing multiple separate stack instances. In conclusion, the circular stack addresses the inherent limitations of traditional stack structures, which operate strictly under the LIFO principle and allow operations from only one end. By enabling push and pop operations from both the front and back, circular stacks provide greater flexibility and efficiency in data management. Circular stacks excel at efficiently managing multiple data sets with a single stack structure. This capability reduces memory overhead and streamlines operations, making it easier to handle complex applications that require frequent insertion and removals from both the ends of the stack. The applications of Circular Stack are extensive and diverse, spanning various fields in computing and system optimization. They are particularly valuable in areas such as CPU scheduling, memory management, and real time data processing. Their ability to enhance performance and optimize resource utilization makes them a crucial data structure in modern computing environments. With this, I would like to conclude the presentation here. Thank you so much for watching. See you in the next video.